So I guess we're going to now test my computer science skills and see where we put the talk. Let's see here. Here we go. Yep, got it. Thank you. And let's go to the beginning. Great. So we went through the first slide. Thank you so much, Vishy. I want to spend the next 40 minutes going through green, but I'm going to do it in a slightly different way than perhaps the way we've thought about it. Let me put a few more numbers together for you. So I've shown here data growth over the next 5 years. It depends on who you talk to. Cisco says, projects about a 28 times increase in data use. Other calculations show about a factor of 100 increase of data use. It's not surprising. The graph on the right shows the what it's being used for. The graph on the left shows you where it's coming from. Mobile is taking off. So today in India, there's about a 5% penetration of smartphones, about 5 million handsets. That's going to grow to about 45 million handsets over the next few years. You cannot stop it. It's going and it's increasing throughout the world. And so but this is from a demand side. We all like to download video, look at things, do all of that. And of course, it has a lot of consequences from the supply side, affordability and whatnot. When you think about these curves and a factor of 30 improvement or increase, I want to point out something that is often overlooked. The networks today, whether they are wireless or wireline backhaul, or even the optical transport in the core, are all operating at the Shannon limit. They are all operating within a few dB of the Shannon limit. So how are we going to support this 30-so increase in traffic? That's actually one of the most fundamental questions we have in our industry today. Because in the past, the way we've supported this phenomenal growth is with increasing the spectral efficiency of these systems. We've spent the last 40 years approaching the Shannon limit of these systems. And so we've made the transition in an industry from analog to digital, from circuit to packet, to higher order constellations, to spatial mode coding. And we're even now doing spatial coding in fibers themselves. So we as an industry have exhausted that potential. Now, in India, as well as the rest of the world on the wireless side, there is a spectrum crunch as well, particularly over the next 5 years. Because as governments struggle to balance their budgets and whatnot, whatever small allocation they have available to them will be very expensive. So we may get a factor of 2 or so in terms of spectrum. We really can't get much in terms of spectral efficiency. So we're still off by a factor of 15 at a minimum. This means that the number of base stations, the number of equipment, the number of networks, overlay networks, whether it's small cells, femtocells, whatever, is going to increase by at least a factor of 10 in our industry. And this leads to one of the most fundamental crises we face for a very long time. Because the numbers that Vichy pointed out, 70% operational expense, that's just the electrical bill in the operational expense, the cash expense. There is not an operator on the planet who can increase their operational expense, the cash expense, by a factor of 5. Every operator is challenged from a margin perspective. So there is this complete mismatch in our industry between the demand growing by a factor of 30 or so and the supply, the affordability of doing this. So while we typically think in terms of base stations or carbon emissions or rural access, each one of these things by themselves would justify the investment, the intellectual investment in green. Each one. We have in India about 350,000 base stations. That will be growing to over 500,000 base stations, primarily for rural access. We have over 5 million tons of annual emissions in India in terms of carbon emissions because of the diesel fuel that Vichy outlined. We still have a tremendous amount of people, particularly in rural India, that don't have coverage and can't participate in the digital divide inside of India. So each one of these three is important by itself. But our industry, both in India and globally, cannot sustain the demand in an affordable way. Because Indian subscribers, as well as the rest of the world, the ARPUs are different, but nevertheless, can't take the increased electrical cost. So this is fundamental to the growth of India, and it's fundamental to the growth of the internet technology sector as a whole, globally. Every operator, every government, every region of the world sees the same fate. So this is a perfect opportunity for IISc and other universities and other research institutions around the world to really get into the fundamentals of energy, not only for the aesthetics, not only for carbon emissions and global warming, not only for rural access and broad participation in the digital divide, but also in terms of the financial resources and the continued financial success of this industry. So I'm going to spend the rest of my talk going into each one of these things in detail and exploring the research opportunities in front of us. I do welcome any questions, and we can, either at the end or if there's a question on clarity, please feel free to raise your hand, because the topic that we're discussing is incredibly important, and I don't want to spend too much time going forward if there's a question of clarity or whatnot at a particular moment, because each one builds on itself. So when we take a look at the ICT industry, it emits about the same amount of carbon dioxide as the aviation industry. And it's broken into three large components. About half of it is in computers, peripherals, and things like that. Displays, all of the end equipment. And then the other two pieces are broken roughly half between the network itself and data centers. And so the network, if you think about it, represents about 1 to 2% of the global greenhouse gas emissions. It is one of the fastest growing segments and is predicted, if nothing else changes, to occupy about 4% of global greenhouse emissions. And this, again, is a tremendous result from a planet and global warming perspective. But it's also, ICT represents a very, very unique opportunity inside of our industry as well, because while it actually emits, when you think about base stations and routers and things like that, it can also offset other industries by making them more efficient. So let's take a look at this graph here. Here's tons of CO2 emitted on the y-axis, the time on the x-axis. And if we just project the first three, this is ICT industry, business as usual, and just kind of extrapolating out the growth. But of course, we can use the internet and ICT technologies to make transportation more efficient, to make utilities more efficient, to make business operations more efficient, and on and on and on. And when you make these other industries more efficient, you then, of course, have to subtract the amount of carbon dioxide saved from those other industries. So when you take a look at the ICT industry holistically, you add the greenhouse emissions from the ICT industry, and then you subtract the greenhouse emissions saved by using ICT in other industries. And when you do that calculation, you find that even with this growth, the overall equation is negative, with a reduction of almost 8 gigatons of carbon dioxide. And that represents about 15% overall reduction globally in terms of greenhouse gas emissions. So this, using ICT, actually helps reduce emissions, even though we explained before all of the complications in doing so. So this is why I focused early on the economics. Because from a greenhouse gas emissions perspective, using even more ICT, using even more wireless and sensors and things like that is a good idea, because overall it is more efficient, but it puts even more economic pressure on our industry. It means even more traffic on there. What I showed there was just consumer use. When you start putting on all of this other stuff, it makes the equation, economic equation, even more untenable. And so this is why it's not just from a business perspective of the wireless industry or the telco equipment, but it actually has a huge lever arm from a global greenhouse gas emissions perspective as well. And so, again, it's important. I mentioned early on that we are at the Shannon limit. I show some curves here showing how close we are to the Shannon limit from a spectral efficiency perspective. I also want to point out on the curve in the upper left that as an industry, from a power perspective, we have really leveraged and taken advantage of Moore's Law, the doubling of performance every few years. Because as you scale in terms of Moore's Law by reducing the dimensions, you also have to scale the voltage to take advantage of that as well. And then, of course, the power goes as the voltage squared. So this is leveraging Moore's Law has also been a tremendous boost from an energy perspective as well. But of course, as the dimensions scale further and further, and you continue to scale the voltage, then you start to operate closer and closer to the thermal limits, which introduce noise into the calculations. And so, of course, the error rate goes up inside of the circuits. And so to stay well away from